In this we do problem, they say element 117 was recently discovered and is named tennessine. Assuming that the periodic trends are followed, write the noble gas electron configuration and then predict the formula when it forms an ionic compound with magnesium. So let's go ahead and do the noble gas electron configuration first. And I'm glad they said noble gas configuration because tennessine, symbol TS, is found right there. And it's in group 17. So we know it most likely is going to behave similar to a halogen, but it actually has 117 electrons. So the noble gas configuration, remember, we're going to start with the noble gas that shows up before tennessine, which happens to be radon. And we're going to put radon in brackets. So radon, and then we go to the next row right here through the S block. And remember, this is 1, 2, 3, 4, 5, 6, and this is period 7. So it's going to be 7s2, and then that sublevel is full. Then we're going to drop down. Remember, the F block is 2 energy levels lower than the period number that it's in. So this is going to be 4, and that's going to be 5. So now we're going to go all the way through the F block, and that is going to be 5F, and there are 14 elements all the way across. So we have 5F14. Then back up to the D block, and remember the D block is period number -1, so that's going to be 6D10. And then to get to tennessine, we go 1, 2, 3, 4, 5. And so we're back in the 7th period in the P block, and it is the 5th element in. And that's the electron configuration for tennessine. It's also perfectly fine to rearrange these according to their energy numbers. So another way you could write this is to put radon in brackets and then list the lowest energy level first. So the 5F14, then the 6D10, then the 7S2, and then the 7P5. So we can see tennessine is 1 electron away from having a full valence shell. Shows up right there. If we had one more, we would have 8 electrons in the 7th energy level there in the S and the P block. So we know tennessine is going to act very similar to the halogens when it comes to giving or taking electrons. So magnesium is in group 2. So we know magnesium is going to have a 2+ charge. If you think about tennessine being really similar to the other halogens, that means tennessine is probably going to have a -1 charge. It is a group 7 halogen. And magnesium is group 2. So when they form a compound, an ionic compound with the give and take of electrons, remember the overall goal is to have a charge of 0. We're going to need 2 tennessine. So it's going to be MgTs2.